Tonight's presentation is the AeroVee Turbo engine, and our presenter is Jeremy Monnett. Jeremy is the CEO of Sonex Aircraft. He holds a private pilot certificate with glider and float ratings. He's a mechanical engineer. He's been with Sonex since 1998 and is a lifetime member of the EAA. Jeremy, thank you so much for volunteering your time to be with us tonight and sharing information about this exciting new engine that Sonex Aircraft has developed. I'm going to turn control of the presentation over to you.
Good evening, everyone, and welcome back. I'd like to thank EAA and all of our friends on the other end of the field for continuing to help us put on what I think has been a very successful grouping of webinars these past few years. And I hope to provide the latest detailed information on our AeroVee Turbo package, which you see in the picture in front of you. And the way I'm going to progress through the presentation tonight is to give you a very, very brief and quick background on the AeroVee power plant in general. I think we'd be remiss if we didn't at least go through where this is coming from for those of you that are not familiar. And those of you that have not learned about a lot about the interior of the AeroVee, I invite you to watch a webinar that my father just recorded this past year on the engines before us. A lot of what he learned in developing these packages. And there's also a separate webinar on the AeroVee development in general, but there's a few new things to talk about there. So without further ado, let's get to it. The AeroVee Turbo, I put a date in the lower right-hand corner, so those of you watching this as a recorded presentation will get an idea of when this was filmed, and some of the material in here will be dated. But I'd like to start with a brief history of where this AeroVee package came from. And you can see this is kind of the modern AeroVee. We're referring to it as the 2.1 engine that we're selling right now, and there's my father and I flying over Lakeland in 2001. So the AeroVee engine, VW engines have been, my father has been a great champion of the Volkswagen. We call them VW Volkswagen engines. In reality, what we use are really derivatives of the VW engine. They're the racing cores, and the same parts that people are using to do dune buggy racers, dune buggy Baja racing kind of thing, as well as dragsters. So these engines, these core parts, are definitely racing core parts, and they're built to be flown and run hard. So in the foreground here we have the Onex from 1982, still the world's fastest ultralight, and it is in the EAA's permanent collection, currently sitting over at the Whitman Airport Regional Terminal. And we also have the Walex in the background, and I know a few of you out there tuning in tonight are building that very similar airplane to the Walex, the Sonex family. Also very proud to be AeroVee VW powered. But it's pretty amazing what my father, I think, has done with the Volkswagen engine package, the racing cores of the past and present. Here is the AeroCarb. We always like to start the story with the AeroCarb, because the AeroCarb really existed because of this engine, the Jabiru engine. We came up, you can see the little red AeroCarb at the back of the Jabiru, which we still market and sell for this package. And this carburetor really exists because of the carburetor that was shipped with the Jabiru engines, which we're not a fan of. Thought we could do a little better mousetrap and have developed and refined it through the years to have a number of different features. It's a very versatile product, a very versatile carburetor. And again, it's one of the things that has allowed us to do so much development in such a short amount of time on the turbo package in customizing the fuel intake system to it. It's been refined and over the years, and here's an example of how it works. With the carburetor, you have a half round slide with a tapered needle, so you have fuel that comes in here and runs through the orifice to the center venturi of the carburetor, and then you have a tapered needle that meters the amount of fuel. A little amount of fuel where the taper is small there, and a lot of fuel where the taper is larger. So basically, as you advance the throttle, you're letting more air in and more fuel in, and you just have a few adjustments to make this work with many different power settings and many different engines. Here's the AeroVee test stand as it sat right outside where I'm sitting right now back in 2001. He had a big test club on it. Some of these parts look familiar. The intake manifold, the aero carb, now aero injector, very simple exhaust system, and these very accessory case, machined accessory case and manifolds. So here's the AeroVee Sonex again. I talked about that one. Dad and I flying it back in '01, and now we fast forward 9 years. So we just took a big leap forward to explain the current AeroVee 2.1 offering, and there isn't much in this picture that you see here that hasn't seen some kind of refinement over the years, other than the two things I just pointed out, the intake elbows and the basic accessory case on the back of this engine. Otherwise, just about every other system and part has been touched and refined through those years. We're very proud of that. AeroVee 2.1, just some of the features as I breeze through these, is the drive lugs and prop hub right here in the front. We use drive bushings to drive our wooden propellers. It distributes the load, which is very important when you get into the higher horsepower like a turbo, in transferring the power properly from the engine to the propeller. And here is what the current AeroVee prop hub crankshaft system looks like, in my opinion, and it is a very experienced opinion now and knowledgeable opinion. It is the strongest crankshaft put out for a Volkswagen engine, period. And I believe we can take many other aircraft-specific engines on as well in the overall strength of this crank. Custom forged nitrided 4340 crank. We use the standard racing bearings, which you can see how close together they are and fully supported with a fairly short propeller hub that is a shrink fit hub. And it's really proven itself through the years, especially since we've come out with this 2.1 custom version. And here's the accessory mount we talked about, the red parts. The CNC technology has really allowed us to work some really, I think, attractive parts and some very stout, robust component parts to adapt the racing VW core for aviation use. Starting with the back end, here's what the accessory case looks like. We do a lot with this, what my dad has coined the X mount. He was the original developer of this system that adapts the 4 main mount holes from the crank case of a Volkswagen engine to 4 mount locations for a motor mount. Basically pushes those mount locations out so you have room for all this stuff in the middle. The stuff in the middle would be the starter goes here, the alternator goes here. It's very accessible. You can pull these 6 cap screws out and do your service to it, put it all back together without pulling the engine off the mount even. Here's the magnetron units would go top and bottom here. So we do a lot with this accessory mount. And here's the newest ignition system. This is right off of your lawnmower. L-head twin, Briggs & Stratton lawnmower. Just about every one of them that's a 2-cylinder version has this unit on it. So it is excited by a single magnet. North, south, north is the poles, sweeps through. Breaks a coil, fires plugs. Just about a bulletproof system. We use 2 of these to operate the whole engine, and then we have a wasted spark because the magnet sweeps through at each stroke, compression and exhaust. Here's the AeroVee secondary 12-volt ignition. So everything you see in this picture has been touched by Sonex in some way, including our own custom red ignition coils, our own ignition pickups. The reason we went the extra step and developed those ourselves, we weren't happy with the reliability of these original triggers we were used on motorcycles mainly, and we weren't happy with the power consumption of these coils, the other types of coils we were using, so we developed our own. And this is just a little trigger magnet, runs at crankshaft speed, so similar setup. It sweeps through the Hall effect, gets picked up with a signal to the ignition coil, and that's what fires the spark plug. So again, wasted spark, true dual ignition, top and bottom. And there's what the sensors look like all installed, and that's where the trigger magnet is. So fully adjustable, you loosen the cap screw and can adjust and time the secondary system to the primary. Then here's what the 20 amp alternator looks like. So, electrical airplanes, certainly modern airplanes require the devices, the modern devices. And to have modern devices sure is nice to have charging, and then you want to have starter and a full electrical system. So, this looks like a little radial engine that's been potted, but it's a bunch of windings and then some alternating north-south-north magnets that this thing alternates around, generates a current, and charges your stuff. Here's the Aero. By the way, that's a 20 amp alternator. So you can run lights and all the modern avionics and even charge your iPhone, iPad, and any other device on it. There's your Aero injector, which is the refined AeroCarb. Works just like that second slide you saw, just a lot lighter and a lot more refined. And it's a little more compact in size. Always good to be a little bit smaller and do the things that you can do. And here's what the package looks like today. So this is if you unpacked a box today and put it out for an AeroVee engine kit, and put it out on the hangar floor, this is what you'd see. So now, the reason you all tuned in tonight was really to talk a little more about the AeroVee Turbo. And this is some of these slides will look familiar to those of you that did catch up with this at AirVenture, but I know there's a lot of excitement about it, and it is warranted. Here's the 2010 began the project with a proof of concept. You see the turbo here is down low, and the AeroCarb aero injector is plugged right into it. Has kind of a longer intake manifold tube, kind of a longer exhaust system. So we learned a lot in running this system and flying this system. And over time, and many iterations came up with this system. And you can see the turbo is more on the center line of the engine, a shorter intake manifold, shorter intake from the carburetor, still retain the gravity feed with the aero injector down low. A number of different exhaust systems can be put on it. This was just for our test cell and now resides on our display engine. But everything else looks pretty familiar. So we're going to go through in detail what the differences are between this turbo package and the standard AeroVee package. So we'll start with a question. Why? Why do you even want a turbocharger on an AeroVee engine? Well, the first reason is the same reason that many cars and trucks have turbochargers today. In fact, there's a good chance that your car or truck has a turbocharger on it. They pressurize the intake charge of the engine to increase the power output. If you can increase the air density of the charge, that means it'll hold more fuel and add more fuel and make more power. And there's a reason for this logo that you all saw earlier this year from Volkswagen itself, the car company, Volkswagen Turbocharged sales event. They made a big deal of this, and there's a reason for that. Reason number two, a huge added benefit to more power at sea level is keeping more of the power at altitude. So as pilots, we're not flying at sea level. We're never flying below sea level. Which would be great, wouldn't it? Have even higher air densities. But as we climb up in air, the air gets thinner, and therefore your normally aspirated engines have trouble keeping up with the power output. So for a Sonex, this means a higher cruise speed at 8,000 feet for an AeroVee Turbo versus a 120 horsepower rated 3300 Jabiru because it's not turbocharged. So this is truly a turbocharger is a perfect product for those of you operating in a higher field elevation, which are a lot of you in the high desert or anywhere else. Why a turbocharger on an AeroVee? It's built on the proven, reason three, it's proven on the proven AeroVee engine package. We have always preached, and my father, we've taken the lead on this, we followed his lead on this, he's always preached maximizing reliability while still trying to get a lot of power, or as much power as you possibly can. So an 8-to-1 compression ratio on these core racing parts is not asking that much out of them. And now we're going to put a little more stress into them. We're going to run at a little higher pressure. So a lot of what this program has been is ensuring that we're not going to increase power at a cost to reliability. It took us so many years to come out with this. Reason number four, the best value not only comes from the low front-end price of the AeroVee, but the lower ongoing maintenance cost. So these, I keep saying, these racing core service parts can be priced from a number of different places. The built-in market are all the guys running Baja and dragsters and high-performance Beetles. man, they provide a market for 10,000, 20,000 of these parts a year. So we're using a small fraction of that, but that's really keeping the money down. Here is a picture of our test cell. Spent a lot of time here with our team. There's my father, John, and there's Joe Norris, who put in a lot of work on this program. But the test cell was just a godsend as far as conducting little experiments. Things like changing the size of the oil supply line to the turbo, changing the size of the oil return line, changing the orientation of the fittings, changing the compression ratios, on and on. The oil levels, little simple things like that matter. And that's all been now refined and put into our documentation we're going to get to in a little bit. But love this. I mean, this is green. And we can take screenshots from any of our runs, and that's what they look like. Very important to home builders, to people building airplanes. We're experimenting enough by building our own airplanes. We hate it when we have unpleasant surprises like things not fitting that are supposed to. So this picture illustrates the tightest motor mount configuration we have, which is a Onex motor mount. And in the test cell right now, we actually have the tricycle gear Onex mount in there and on the engine, and everything clears it. This picture of the back end probably tells the story the best. Now this the Onex exhaust actually comes out and hops over and down this tube, but we've worked all that out for you, which is great. So the AeroVee Turbo package will work on any of our family of aircraft. So that would be the Onex standard gear, the Onex tricycle gear, the Walex, the Sonex, the Xenos, any of those with all their configurations, tricycle gear included, except the subsonics. AeroVee Turbo package. So what's included in the package? So we want to really slow things down here. I want to. And really make sure we go through the features so you all understand what is included in this package and what we went through to get you there. Lots of custom tubes. Intake manifold with the manifold pressure provision, because we're going to get to why manifold pressure is so important in a moment. But the exhaust system, turbo mount, the intake tubes. So this is the intake tube from the aero injector up into the turbo. So that would be the one of the wheels in the turbo. And the other one would be the outlet wheel in the back. So all these tubes, you can see the main exhaust itself is a fairly complex system. It's the same basically on each side as our 2-into-1 exhaust, which clearly fits in the cowlings and clears everything. And they're cut off here at the joint. And then a cross tube is put in. So this is a new custom tube, and this is a new custom tube, and then we laser cut the plate that the turbo sits on. So a lot of engineering and refinement went just into the exhaust and intake manifold tubes. This is what they look like. This is how they'll be delivered to you. These are stock items that I took all these pictures with the brown paper this morning as I pulled parts off the shelf to illustrate what's included. So these are the manifold tubes, and then here are it's an intake tube for the Onex, which is actually made out of aluminum and going to be anodized. The AeroVee 2.1 also includes the turbo upgrade, the new silicone couplers. So we've had really good luck with these silicone couplers as we've flown with them. We like how they seal the intake manifolds. We like how they've held up. And we believe they're a really nice upgrade to the system, and that's what they look like when you unpack them from the box. And a lot of people have now chosen to upgrade their AeroVees to these new reduced silicone couplers, and you can purchase those as a separate item. The turbo, also the oil sump machine for oil return for the oil separator. This is a permanent oil filter, and there it is right there. And this permanent oil filter sits in this little sump, which then bolts to the bottom of the engine. That's what we're looking up at the bottom of the crankcase. And all the oil runs through this. So it gets picked up right from the center of the oil filter. So now we have, for those of you that have always wanted a permanent oil filter, even in your standard AeroVee, you could add this and go to it. Gives you a little more oil capacity too as an extra special gift. We sell it for 165 bucks. We have done this operation here. We've actually drilled and tapped the bottom as low as we could go for this return line. So this would come from your oil separator to drain oil back into the engine, goes through the filter and gets sucked up the intake tube, and away you go. So it's a nice little unit. ACV P0675 is the part number for those of you wishing to order it. We just added it to the web store today, so ready to rock. The new oil sump machine for a return, that I didn't update this. This is the secondary oil pump, is what I meant to show in these pictures. This secondary oil pump plugs into the front of the engine. The propeller hub is right here. So you're looking up at it, and this is the front of the engine where my little arrow is. And this provides the oil system for the turbo. So this would be the return line for the turbo, and it's an entire secondary oil pump system. And it's isolated from the other pump system with some modifications we make to this pump. So it comes in and then goes out and dumps back into the rocker cover, and then drains back down, goes through the filter, and goes through the whole system again. So this is a way of supplying oil to your turbo. It's worked really great. The turbo itself. Carbon seals are installed from the factory for pull-through operation. And the only modification we made is for the internal wastegating. So we now have a custom, this is where your exhaust would plug on in this 5-hole plate here. And this is the chamber we've removed to allow your wastegate to function with this set turbo. So it's off a diesel truck, this turbo. It took a long time to find, and it is in current production. So this is how it's delivered to us at the factory, which is wonderful. So we're able to ensure a good supply and take care of what I think will be a very high demand. Also took a while to find this billeted wastegate actuator, and we did do our custom mount bracket hardware, so you don't have to worry about that. But it's got a spring in it, and what this actuator does, it's just got one spring tension to it. So to put it in layman's terms, when you've increased the pressure, the manifold pressure, to a point where we don't want you to anymore, this will be your pressure relief, your parachute. It'll pop off. It's a very subtle action and relieves the pressure in the intake system. So you lose a little power at that moment, but that's before you destroy your engine. So oil supply and drain lines are included in the package. So these are just some screenshots of some of these system components. You can see this would be the oil supply to the turbo, the line. This would be the other side, comes through the crankcase and drains into the turbo. And this is the return line from the turbo that goes into the rocker cover. And then there's the rest of the supply line. So these are right off the shelves. Again, this morning had the guys pick one of everything, and took pictures of each of the setups. So there's a very, like we're famous for, a very detailed packing list showing you exactly which fittings go to which subgroup, and then the manual will take you the rest of the way on how you put it together and plumb it. We've also included all the exhaust accessories and the exhaust heat wrap. So, you know, heat is a real, you're basically using the exhaust heat to drive your turbo to compress the air to make more power. So it's very important, as there is a little more heat in the cowling, obviously, to try to isolate that and get it dumped overboard. So that's why we do use the exhaust heat wrap, and that's what this big coil is. And then these are all of the hose clamps for all the silicone intake things, and then miscellaneous hardware, bolts and nuts and screws, and even extra set of exhaust gaskets. These are the custom brackets I was talking about. You saw this in an earlier picture. This would be for the actuator, wastegate actuator. And this would be the support strap that would run from one of the AeroVee accessory plate bolts down and support the turbo. So, you know, as 18 pounds or so on the turbo itself, so good to have this. And then there's the other plates and gaskets, and this would be the oil supply plate for the turbo. And that, excuse me, oil drain plate for the turbo. And then over here we have the blanket itself that goes around the turbo. You got to put a little slot in it to tie it together. But that again is the idea, is to get the heat just out of the cowling. and shield the rest of the engine from it. So the intake and down tubes specific to the Sonex, Walex, and Xenos or Onex. So we basically only need to know on the order form whether you are doing a Sonex, Walex, Xenos, so that is one type of exhaust, or a Onex, which is another type of exhaust. It has an extra little bend in here to get it overboard. So that's all we really need from you. If you are looking for a non-Sonex installation, then we also devised this U-weld exhaust. All these would be the same diameter tubing. I just took a picture to visually represent. Includes a thick laser cut stainless plate, a stainless U-bend, a stainless 45, and a straight bend. So then you can weld up your own exhaust for your own airplane. And I anticipate once word spreads about what this little AeroVee Turbo does for the price, I think you're going to see a lot of people put them on a lot of different airplanes. So the Turbo Complete Engine Kit includes all the upgrade items plus everything in this picture, obviously, except for this intake manifold, the standard manifold. So shortly, in the next few weeks here, we'll take a new clean picture of the whole Turbo upgrade and Turbo package and be able to show that to you. Now the Turbo Assembly Manual. This is, again, one of the things Sonex Aircraft has become very famous for. And I think we've worked really hard, put a lot of time into the documentation. And this is, Carrie has, for us, has again done this turbo assembly and installation manual and shows you the turbo picture. And here's a brief of the table of contents of just what this includes. So there's, at quick glance, 71 different sections to the AeroVee Turbo manual, which is very, very detailed. For those of you that like good instructions, those of you that like to follow instructions, here's your manual. Here's a few excerpts. These are just 2 pages pulled kind of randomly, but they show what I consider to be 2 key systems to the turbo use and development. They show the dual pump installation, and this is the way the standard AeroVee manual works, which you can download from our website now and take a look at. But it gives you the list of parts required with little check lines there, and literally step-by-step instructions of what you do to complete the installation. Very, very detailed. And then over here would be the mini sump installation. So again, as I predict, this will be popular even for those of you using normally aspirated AeroVees. You can plug this little hole, or you can use it for a return line and have a permanent oil filter, which many of you have wanted for years. Although I really still find it unnecessary. I think for the turbo, it's a requirement to keep all those little particulates out of there. And then here is the top-mounted oil cooler instructions. So this is the little top-mounted oil cooler plate right here. We started marketing this for the Onex. It's kind of become a standard for the Onex. And with the turbo installation, though, you Sonex guys are still going to need to put an oil cooler somewhere. So I think this makes a very robust, simple place to put your oil cooler. You do have to notch out or grind away just this top plate. The oil doesn't start until the second plate down here to clear your sloping cowling and your piano hinge. So we've now put this on all of our factory Sonexes, Walexes. And again, very convenient thing to do to do an oil cooler. And here, I'll let you spend a little time looking at this. This is a real core procedure. It's actually bolting the turbo and actuator and bracket to the exhaust. And you can see here it runs right down the list by part number, which cross-lists with your packing list of exactly what you need. And then it launches right into what you do at each step, kind of step by step. Are there other ways to do this? Of course. This is just one way. It's the method that's worked for us. It's the method we followed at the factory. And I recommend, if you want a fairly smooth running project, that you follow those instructions. Other documentation, the AeroVee assembly manual, you could order that today and start getting yourself ready for putting your own engine together, which I think is a brilliant thing to do. And then the aero injector owner's manual, it has its own little manual in operation, very detailed on how you go through it. So now more meat of the presentation. I'm kind of going to tell the rest of this story in terms of frequently asked questions. And I'll get right to it. Aren't the temperatures for a turbo much higher with this installation? Answer is no. This is by far our most pleasant finding. In the test cell and later on in flight testing, we're able to run in the green with all the major engine parameters using the published specs. I am ecstatic, and I was probably among the chief skeptics until I actually started doing it myself and seeing it myself. And I was just tickled with how you could increase the EGTs and just get them right across. This CHT 3 and 4 tend to be a little bit cooler in our installations, so what? So a few degrees cooler. Hooray, they're all green, we're running happy, and the engines have just been extremely good, extremely healthy. What's the weight difference between the normally aspirated AeroVee and the new Turbo? 25 pounds is the answer. As we have done with the 3300 Jabiru powered Sonex, we've increased the gross weight, and you're going to see, on our website now we have specifications listed for the 80 horsepower AeroVee and the 80 horsepower Jabiru and the 120 horsepower Jabiru. You're now going to see a new column called 100 horsepower AeroVee Turbo appear in the coming weeks, where we've increased the gross weight 50 pounds to give you the extra weight so you don't lose gross weight. What we've been concerned with isn't just the engineering safety factor pulling on the airplanes. I think the Sonex family has as good a safety factor as anyone in terms of the engineering behind it. But we don't want you to cut that margin too much. That's why we're willing to give you 50 pounds for these healthier engines. And the other reason for it is at high density altitudes, power is critical. And you load up an 1,100 pound airplane on a hot, humid day or a high density altitude day in the high desert, and it doesn't want to get off the ground too great. So by limiting the weight, we've kind of kept the power safety factor there, and now we're giving you 50 pounds because we're more comfortable with the power safety factor of the AeroVee Turbo. What propellers have you flight tested with the Turbo? Well, there's quite a few. 4 different, just in the 4 months preceding AirVenture. Since then I've flown 2 more, so we're at 6 propellers that I've personally flown on the AeroVee Turbo. More were tested in earlier versions since 2010, and we're recommending 2 Sensenich propellers with the Sonex family, a cruiser, quote unquote, and a climber or sprinter. And these are on the new prop order form that you can download from our website. Why a fixed pitch prop? A lot of reasons, but here's the main ones: reliable, cost, weight, simplicity, sport pilot compliance. And they all fit in the Sonex philosophy. So all those things are basically the Sonex philosophy. If you go back and review the other webinars and hear my father or I or anybody affiliated with Sonex talk, that's what we aspire to have, are those things. So they work really well, and they also do things like absorb dampen vibration, which is wonderful for direct drive engines, so they result in a nice smooth run. And why 2 props? What were we thinking there? Well, I believe with the Turbo, you kind of have 2 separate missions. Are you going to want to be more the aerobat and go climb, and that's what climb performance comes from? You want to do your loops and rolls and all that stuff faster? Then a climber or a sprinter prop is for you. Or are you going to be more of a cross-country guy? You're going to try to go to all 48 states. Well, then you're going to want more of a cruiser. So what's the performance increase between the normally aspirated 80 and the AeroVee Turbo 100 horsepower? Based on a lot of data, and I mean a lot of data. I'm a bit of a data hound, and that's just my engineering background. That's just my personality. And I would say it probably drives a lot of the people at Sonex a little crazy. But I did my best to summarize, and each of these line items represents a compilation of average data doing multiple runs, and the MGL series instruments that we're running both in the test cell and in the flight airplanes are sampling at every 1 second. So every line item here represents at least a minute, so 60 seconds worth of data, most likely more than that, 2 to 5 minutes of data, all averaged. And you can get some pretty good feeling for what this is doing with those numbers. And I know it's probably hard to see on your screen. I'm going to summarize it really easily for you in the coming slides. But these were all climbs. And you can see down this column, they were climbs at various manifold pressures and at various speeds. So 84 down here at the lowest to 110 miles an hour down here at the highest. And you see VSI averages to, I'm well over 1,000 feet a minute in almost all these runs. And here's what the Sprinter climb prop did in cruise setting. So here I did various altitudes. So going down the line here, you can see the 3,000 foot cruise at the top. Down here at the bottom, I have the 8,000 foot cruises. And there's still some pretty healthy numbers on here. Wow, at 40 inches of manifold pressure, that's a lot. That's really pushing this engine. Doing 180 miles an hour. Holy moly, that rocks. But when we get down to what we expect as a normal operational manifold pressure, so say 28 inches would be a good, easy cruise, even with the Sprinter prop, I'm doing 154 miles. That's pretty awesome. Now we go to the cruiser prop. So this is bigger diameter, a little more pitch, and we end up with lower RPMs in general. Certainly lower climb rates, so you're trading climb performance for cruise performance, but you're gaining it when we take that same cruiser prop and we start running it at altitude over a longer duration. We're doing better performance with a lower RPM, therefore the fuel burn will be a little better. So you kind of should pick, in my opinion, pick one horse for the appropriate course. So based on the standardized flight testing, the AeroVee Turbo on a Sonex results in a climb of 700 feet per minute at gross weight at 8,500 feet density altitude. I want you to absorb that for a minute. That's gross weight, and I think that is incredibly impressive. At 8,000 feet, still able to maintain a 700 foot per minute climb. Cruise speeds will also increase more. And I threw some numbers out there, but what do they mean? I think the actual speed delta is going to depend on how hard you're willing to push your AeroVee Turbo. We'll get to that, more of that in just a second here. So how is flying a Turbo AeroVee different than flying a normally aspirated AeroVee? Monitoring manifold pressure is very important, especially during takeoff. A turbo with a fixed wastegate, like our turbo, will allow you to exceed the operating limit. So we're publishing, and will be publishing with your manual and online, a recommended continuous recommended maximum manifold pressure. It's not going to pop off until you get to about 42 to 44 inches of manifold pressure. It's inches of mercury, inches Hg. That's how we monitor it. We can measure it in PSI, measure it in bars, whatever you pick. Make sure you do apples to apples, but we're looking at inches of mercury. 40 inches we're allowing you for a 2-minute maximum. Okay, so we want to maximize the longevity of your engine. We want to teach you how to maximize that longevity, so you got to use your power and burst. Most of you are going to choose to use your 2 minutes of 40 inches at takeoff because you want to blast out of an airport. Great, good for you, do it. 35 inches for climb power max. So we'll allow you to go to 45 inches in a climb. Then once you level off in cruise, it changes a little bit. So anyway, you have to, in a nutshell, you just have to be cognizant of manifold pressure, and that's the difference between a normally aspirated AeroVee pilot, who generally just looks at RPM, and a Turbo AeroVee pilot who's going to look at both manifold pressure and RPM. Is a Sonex, Walex, Xenos, or Onex sport pilot compliant with the Turbo AeroVee? Absolutely yes. We used a maximum continuous cruise of 3,200 RPM for the AeroVee Turbo, and we checked this through flight testing. So at that 3,200 RPM, we were pulling 27 inches of manifold pressure at 3,000 feet, mind you, and indicated 135 miles per hour. So we even have some safety factor because Sport Pilot is measured at sea level. We were at 3,000 feet. So we're comfortably under the 138 mile an hour quote unquote speed limit. If you're an FAA person tuning in, please get rid of the Sport Pilot speed limit. It does nothing but take power away from pilots. If you're not an FAA person, just know that no matter what of our family of aircraft you put the AeroVee Turbo in, you are good to go on Sport Pilot. No question about it. Just like you're good on the 3300 Jabiru. What is the fuel burn rate during a normal cruise? Concise answer, 5 gallons per hour at that same normal cruise setting of 3,200 RPM. That was painstakingly logged and is now being reported. Note these fuel burns are using our Sport Acro Sonex Turbo AeroVee running a 32 millimeter aero injector, which is the aero injector that ships with the standard AeroVee engine, normally aspirated, and ships with the Turbo AeroVee. So there's no need to swap out your aero injector. You've got the one if you want to do the upgrade. And we used a 2.5 needle jet. That is not magic. That's the jet we're using at 800 feet here in Oshkosh. And your mileage may vary. You may choose a different needle jet, which is fine with us. How should I lay out my firewall with accessories to prepare for the turbo installation? Knowing the turbo sits back here on the right-hand side of the airplane, avoid putting the larger accessories like the battery right on the firewall behind this turbo. And you can get a really good feel for it even before you have your package. You can see the line of the turbo and all the stuff is right here in line with the center line of the rocker covers. So avoid that area with accessories. Look to the left side from the pilot's perspective, low, high, whatever. Or even better, wait till you get your engine together, and when you get your motor mount on, do a fit check before you go and plan the rest of your firewall stuff. What internal changes are needed to make to my current AeroVee to retrofit a turbo? None. It's ready to go. 7-to-1 compression, 8-to-1 compression, ready to go. The only exception are the Nikasil cylinders. If you have them, they must be swapped out for the steel cylinders. Steel barrels, the Mala brand, are required for the turbo use. What's up next for the AeroVee turbo testing? Our engine test cell has a 7-to-1 compression ratio turbo AeroVee in it. The one you heard me talking about in the Sport Acro has an 8-to-1 compression ratio, and I've just been ecstatic with its performance. And it's running the same cruise, the 7-to-1 compression, which Joe was running just a few hours ago in our test cell. Again, has its cruise propeller. And we'll be compiling the data on that and comparing it to the 8-to-1 compression and then reporting it back to you. And these results will be shared, and you can then decide what to do with your compression ratio. My advice at this point is if you want to do a retrofit, you're running 7-to-1, leave it at 7-to-1. If you're at 8-to-1 and want to do a retrofit, leave it at 8-to-1 until you have to do some maintenance or other service to the engine, then you can decide then. And the question you're all wondering, what are we charging for this? So I guess you could call this a note from your sponsor. The AeroVee turbo pricing, the engine kit's $10,995. That's everything, including the engine core and all the other component parts for the turbo installation we went through. We do it the same with all our stuff. 1/3 deposit secures the position with the remainder due before shipment. And then if you're just looking at upgrading your AeroVee, normally aspirated to a turbo, I think there's almost 1,000 of those out there, 700-800 AeroVees out there. It'll be about $4,000. Includes intake and exhaust, and full payment gets you in line. And we'll be delivering quite a few in a few weeks. AeroVee turbo options, the recommended options. Really, the air filter for the aero injector I recommend. I think it's a nice clean way to put an air filter on it. And then the oil separator. I love our oil separator. You know, there are a few guys out there using aluminum cans for oil separators. I think they're a good idea with a VW racing core. Other options include the assembled crankshaft, currently about $300. CHT probes are $25 a pop. Throttle quadrants. And the current AeroVee order form lists all these options. This is what the cooling baffles look like, and those are compatible with the turbo. You just got to put the new notch out for the top-mounted oil cooler if you go that route. So when are we delivering? A couple weeks. So November 2014 is almost upon us. And I always like to address this. Why do we have a kit engine? Why is the AeroVee a kit engine? Well, if you can build an airplane, you can build an engine. I 100% agree with that statement. And you can be smarter for it. And every time you go to touch it or maintain it, you're putting money in your pocket. Come fly with me. It's just all work. It's slave, 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 work, work, work here in Oshkosh. I think we're all going to be wishing the weather was like this more with my shorts and my t-shirt on in a few weeks. But right now, come on, fly with me. Go on the tour. And even better, come fly as part of our T-Flight experience. I just spoke with Joe on the phone about an hour ago again and asked him, hey, are we ready to go on the AeroVee Turbo demonstrator? And he agreed with me, yeah. So I think especially for those of you that want to learn how to manage manifold pressure and get a real feel for it, come fly with us. Come to Oshkosh, jump in the airplane and fly with it. Flying season is almost wrapping up here in Oshkosh, but we'll get things kicking as soon as we can in the spring. And I know there's still a couple weeks you can come fly while the weather holds. And we're doing a lot of T-flights in conjunction with the workshop as well. So ways to follow things we're doing at Sonex and the other exciting developments. Visit the R&D website that's here. Join our opt-in email lists. I think those email lists are awesome for those of you that like news to just come to you. So that's the RSS information, and you can find that right on a link on our main site. Please join the Sonex Builders and Pilots Foundation. Our friends over there have done a tremendous job with this email forum. It's not run by Sonex. It's run by fellow Sonex enthusiasts and pilots and experienced builders, and I've really enjoyed what they've done with that forum. And thanks, guys, those of you that are tuning in. We've just been really, really happy and proud of everything you've been able to do to increase safety and promote proper construction and provide that forum. Come to a Sonex workshop. Our weekend workshops are still going strong, and we're doing those 3 times a year. Or come to AirVenture. It's our home show. I think I counted, what we have, 11 airplanes on the field last year, factory airplanes. So please join us. And that's all I've got for now. I'll open it up to any questions that you have. And Tim, if you want to jump in and help me manage some of those, I'd appreciate it.
Fantastic, Jeremy. Absolutely will. We got a number of questions that have come in, so let's jump right in. John's just wondering, could the AeroVee Turbo be used on slow aircraft like a Peton pole?
No question, yes. Yes. Now, we have focused our development, and I'm actually just going to go back a couple of slides here. We've focused our development, obviously, on our own propellers, which we limit to about 56 inches in diameter. I'd recommend the same for the AeroVee Turbo because we're getting the power, the real power here, torque and power of the AeroVee Turbo is still in that sweet spot of 3,000 to 3,400 RPM. So no question you can use it on a slow aircraft, but please consult with an expert propeller maker. As you've heard me mention about 1 million times in this presentation, I fully trust the folks at Sensenik. They know how to run a propeller company. They've been doing it for a long, long time. And they have really dialed in a number of props for this project and could do it for your propeller, for your slower airplane without breaking a sweat.
Great. Jerry's wondering if the torque curve will be posted for the engine online.
Sure. Yeah, we're going to work that. We do have not immediately, it's going to be a while. This just in, my plate could not be any more full. Those of you that are familiar with Sonex and familiar with all the things we have going on, it's a lower priority. simply because I just told you what it does performance-wise at set RPMs, which torque and power, what does that matter? There's no feel to it, in my opinion, and this is from an engineer, shockingly. But we will have it eventually, and we do have a dyno, and we do intend to do those testing. Just it might be a year or so or more. But like I said, dial it in for 100 horsepower, dial it in for a propeller I'm talking about, or whatever you're looking for about that 3,300 RPM, and you'll be a happy camper.
Okay, Keith's wondering, can the new oil sump be used with the bottom-mounted oil cooler, or do you need to use the top-mounted oil cooler to make room for the sump?
You know, with some kind of adapter, Keith, yes, I believe you could. You'd have to keep in mind that you're going to have to push, I'll go to the slide that shows it right here. You're going to have to push the pan, going to do some modifications to that pan, and as you go down, you're probably going to run into the exhaust because of that oil cooler's width. So it's going to take some scratching, some head scratching, and some modification, but yes, where there's a will, there's a way, and I believe you could make it work.
Mike's wondering, he says he doesn't see an intercooler. How do you keep the compressed air fuel cool?
How do you keep it cool? You know, there's good enough. And I guess I've been joking around a lot with my father as of late. My father, John, those of you that know him, he's the artist. And Jeremy tends to be the engineer. To an engineer, good enough is perfect. To an artist, there is no such thing as perfect. What I'm meaning by that answer to your question is that there's some things you could do as an experimenter to increase the performance of our turbo setup. And an intercooler might be a great example of something you could do. Do I think it's worth it? No. But again, you have to kind of take a systems approach to it. You have to think about which one you're going to select, where you're going to put it, how the air is going to flow, how's it going to impact the rest of the system. And those are the kinds of things that we've already done for you. So I think, you know, good enough is perfect here, but you're welcome. This is a beautiful thing, ladies and gentlemen, that our government, particularly in the United States of America, allows us to slap that experimental on the side of our airplane and conduct our own experiments. And I think that's just spectacular and done in a proper way, very safe. So I'd encourage you to do that. I think that's what the system, not encourage, you're welcome to do it if you choose. And if you discover an intercooler that provides more power, I'm all ears.
Hear, hear, United States of America, the land of the free and the land of the experimental aviation. Well said.
Couldn't be prouder, Tim.
Vic just asks, when you wrap the exhaust, you make the steel run hotter. Has the steel been upgraded to avoid higher temp degradation?
It's stainless steel. We use stainless steel in the entire exhaust system. The only thing that's not stainless, as I said before, is the intake system. I just, by the way, got to a slide where those of you that have good resolution on your monitors can see more of these performance numbers. Those of you that are data geeks and really want to go through this. But yeah, that's stainless steel. We'll keep an eye on it. But again, being stainless steel, I'm just skeptical that we're going to have long-term problems. But I've been surprised before, so I'm hopeful we won't.
Cool. Michael, Scott kind of both have questions here about when will the assembly manual for the turbo be available online for customers?
Carrie just gave me the draft copy yesterday. Obviously, our deadline was before we started shipping parts. So my answer to your question is in a couple weeks when we start shipping parts.
A couple weeks. And when did you say you're shipping again?
Mid-November. So that's a couple of weeks. Two
Gotcha.
weeks. Yep. And everything is on track to do so. And so usually those of you that have tuned in before, I'm about as slippery as it comes when it comes to dates because I've had unpleasant surprises in the past with supply chains, and you saw how complex some of these parts are and who we rely on to get them. But that's where we're going to be, a mid to late November time frame, and you can take that to the bank.
Cool. Maybe some Christmas presents out there for some
You
people if
bet.
they drop the hints to the right people at the right time.
Great idea, Tim. Thank you.
Hey, Dwayne's got a question here. Does the engine have to be at idle for a minute or so to run oil through turbo prior to engine shutdown?
I'm sorry, can you repeat that question one more time? Does the
Yeah, Dwayne's wondering if you had to run the engine at idle for a minute or so to let oil run through the turbo prior to shutdown.
I think not really. What I've been doing, and I was scolded about this when I was first by my father, of course. When I was flying, I'm very careful now to make sure the oil is warmed up. That's number one. That's always good practice. And you have, a good oil pressure. But number two, when I come in at the end of the day, the turbo is already cooled down. So as you've taxied in, and even at Oshkosh, it's a pretty short taxi. It's allowed plenty of time to cool and the oil to circulate through this. It's always pumping through the system, so the turbo is always getting oil. You just don't have to worry about that as long as you have good oil pressure. So literally, you just pull it up and shut it down. The only other note of what you have to be careful about when you talk about operating with manifold pressure is you have to be careful about sudden throttle changes. So we want to be real deliberate with our throttle changes in this to lengthen the life of the turbo.
Interesting. Travis is wondering, will you be increasing the gross weight for the Onex also?
I don't see that that's necessary at this point, but I'll take a look at it. I would be comfortable doing something similar as we did with the Sonex if you have more power.
Okay. Gerald's wondering, can the AeroVee engine be used in a pusher configuration?
Yes, it could.
Does
The
cooling
biggest
become more of an issue then, he's
yes,
wondering?
totally. He's absolutely correct, and that's where I was going. A number of different things from an engineering perspective are challenges with pusher installations. So I don't know how many AeroVee turbos we actually have, or normally aspirated AeroVees we have on pushers because of those challenges. Mainly what I'm talking about is mounting the engine. So when you look at a motor mount for a system like this, you kind of have to pick up something on the front end, and you could really just have a look at whatever pusher you are using or looking at using it on. I'd encourage you to go see if any other Volkswagen derivatives or conversions have been put on those pushers and see what they did from a motor mount perspective, and probably something similar could be done on an AeroVee or an AeroVee Turbo, but we just don't know it. It's not something that my father and I or anybody else on our team has a lot of experience with, so we've been relatively mum on recommending it, and kind of be on your own in figuring out how to do it.
Okay. Andrew says, hi, Jeremy. Thanks for all the info. What happened to the ground adjustable prop option? I remember from
Yes.
an earlier presentation that this was being used in turbo testing.
Yeah, it was, and it's not anymore. And that's about all I have to say about it for now.
Okay. Jim's wondering about, with the increased cruise, true airspeed, what flight testing was done to confirm no flutter. So maybe another question to add to that, was there any increase in VNE with this engine installed?
No, no, the VNE is not a factor of that testing at all. The VNE really comes out of our structural capability, period, in the wing design. So no, we're not looking at a VNE increase, nor is it necessary, because keep in mind, everyone out there, we've been operating for a lot of years now with a 120 horsepower Jabiru engine on the front end of our Sonex series. We know the engine extremely well, and we know it at that power setting. The Jabiru 3300 at 120 horse still kicks the pants off, not kicks the pants off of, but beats the AeroVee Turbo at sea level performance. And that's where you're flying most of the time anyway, or most of us are. So I just don't see any additional testing as necessary because people have been ringing these things out with the 3300 Jabiru for many years.
Okay, Robert, just wondering, do you accept exchange of new Nikasil cylinders? Sounds like he has some new Nikasil cylinders he hasn't used yet.
Yeah,
And also, Mark, then why are the steel cylinders required for the turbo upgrade?
sure. I'd be happy to cover both of those. Exchanges for the Nicosils, no, unfortunately, because we just discontinued that product line. It started with us not being able to get them. And so basically, I have no use for them at this point, especially as I consider strongly moving to the turbo package. By the way, I didn't say this in a previous slide, but we are going to take that 7-to-1 compression AeroVee engine that's in our test cell right now, and it is going to move to our Onex tri-gear prototype. So we're already at least changing one of our factory engines up to a turbo and may consider others. So unfortunately, no. Those guys that do have Nicosils in the box, because of the supply chain problems, they have been successful in selling those online to, again, those dune buggy race people and the dragsters and anybody else that would want to save some weight in their VW engine. So they're not worthless, but Sonex just isn't exchanging them. On to why you need the steel cylinders, because they're more robust. We had an unpleasant finding in that time period between 2010 when you saw that first iteration of the turbo and present time. We actually had Nicosils on an AeroVee core, and it didn't go well. So please take my advice and heed my advice to go to the steel cylinders.
Okay, and Mark's just wondering if any of the turbo engines are flying and how many hours might have on it.
Yeah, you bet they are on our factory prototype. And we've been flying it since I gave 3 different presentations on it at AirVenture this year. And it had been flying since, February of this year. And before that, had a lot of testing in our ground cell. So lots of flight time, lots of ground run time, and more coming.
Cool. And Jeff's wondering, what about fuel for the turbo and the different compression ratios? Is there any special requirement for fuel?
Yeah, the reason we're interested in the 7-to-1 is to look at auto fuel. I know many of you out there are interested in running auto fuel on your auto derivative engine, as are we. We like to save money if we can. We're cheap, but hopefully in an intelligent manner. Right now, I've exclusively been running 100 low lead in our 8-to-1 compression turbo setup, and I have had not even the hint of a temperature problem, which is wonderful. So I can vouch fully for that setup. Part of the test setup and test strategy in moving the 7-to-1 compression, first do it in the test cell, is to run a few tanks of auto fuel and report back to you on how that went, and then to run a few tankfuls as we move it over to the Tri-Gear Onex. So I'll have a lot more information for you soon. Again, the earliest anyone out there is going to need that information is in 2 to 3 weeks when we start shipping turbo parts.
Sounds like as it stands right now, though, you've only tested 100 low lead.
That is correct.
Yep. And Jim's got a question here. What is the turbo impact on engine TBO?
That is to be determined. First off, on TBO, it has no meaning in our world because AeroVee, AeroConversion, Sonex, whoever you're going to choose to call the mother company of this, does not mandate that you must tear down your engine at a set interval. So I know what you meant by the question, but I just always take the opportunity to educate. We don't use TBO in our world. When will we actually have to overhaul the engine? When you're not making power and you need not making as much power. By the time you get enough running on this engine, and I've got plenty on it now in our Sport Acro Sonex here at the factory, I could go fly it tomorrow and I could tell you if it's lost 5% of power. I just can, because I know the engine and performance that well, and you will too when you start flying it. So that's when you're going to have to overhaul your engine. And the good news is it only costs you a few $100 for a VW core engine. But I know where you're going with it. What does the turbo do to reliability? To be determined. There's no question that you're stressing the core engine more. But in everything that I've seen, including all the temperatures and oil pressure and oil temperature, we're not stressing it that much more. So I would expect, and I do expect, an overhaul period for the Turbo AeroVee to be approximately the same as a normally aspirated AeroVee, perhaps a little bit less.
Cool. Question from John. He's wondering, what oil cooler do you recommend to replace mine on the Sonex?
Sure. So if you're going to do the Sonex installation for a turbo, I'd go with the top-mounted oil cooler. And that part number is listed in that excerpt of the manual that I showed you. So I recommend the top-mounted oil cooler. That's just my personal recommendation shown in this picture right here. Even for a Sonex, you got to notch it out a little bit for the cowling and the pin. But it's a very robust installation. It's very simple.
Awesome. Okay, Stan is just wondering, what kind of cylinder head temps are you seeing at full boost?
Yep, at full boost, I haven't seen anything north of, I think it was 385 degrees. That's pretty darn good, right in the green.
Great. And Francis is just, go ahead, did you have more to add?
No, that's all I have to say. I mean, this is just a screenshot, but the CHTs would be in the lower right-hand corner. This would be a 330 temperature. So in this situation of going 170 true airspeed at 8,000 feet, where's my boost? My little thing is blocking it, 34.5 inches. So that's really what I'm recommending as a good, cruise setting. And we're not stressing this engine at all. And there's your EGTs, all green.
Nice. Francis is just asking, is there a heat shield material on the exhaust pipes from the cylinder heads to the turbo?
Yes. Yep, we wrap the whole thing. So I'll get to that slide for you to actually show it to you. Yep. So we provide that as a roll of heat shield material. I'll find it here. While you're finding the next question, Tim, there it is. So that's the answer to your question right there. You see the wrap is on the exhaust from the heads, coming down around, from the head up there down around to the turbo.
Okay, fantastic. And Alan just wonders if you have thought about trying ceramic coating for the exhaust, perhaps, instead of stainless.
Sure. Yeah, I mean, a ceramic coating, to me, what we have going for us right now is a tremendously positive track record of about a dozen years of running stainless steel exhausts on our AeroVee normally aspirated engines, and those things have held up remarkably well. And I think you can talk to other AeroVee owners out there who have had their exhausts since as long as they've had the engine, and they'll probably depressingly last longer than the engine. I just love the stainless. It's worked great. There's been a wives' tale, and I believe that this is what I really have enjoyed about my 15, 16 years of experience now at Sonex, is when I first came to work here at Sonex, I first started getting involved in Volkswagen engines and aircraft design and development. I heard a lot of wives' tales. And, I've been able to prove a lot of those wives' tales either fact or fiction. In the case of stainless steel exhausts cracking on Volkswagen engines, fiction. But certainly we have had some plain steel. We had a batch of 4 straight pipe exhausts that were mistakenly made from plain steel. I had them ceramic coated, and I sold them on eBay. And I don't know, we'll have to go find those guys and see if they're still holding up.
Okay, Daniel's just wondering, for the 2 minutes at 40 inches of mercury manifold pressure, is that per flight, or is there a required time at cruise pressure before you could use the 40 inches again?
So first off, it's an experimental engine, so I can't make you do anything. But I believe I understand your question fully, that you're asking me what do we recommend, as an interval. Joe and I, my father, the rest of the tech crew here, we're saying you get 2 minutes at 40 inches per flight. And that's where we'd be comfortable to try to honor that maximizing the life of the engine statement. I've gone out and run this thing incredibly hard for a lot longer durations, but that's what I'm trying to do, to be blunt, is to break it. I'm trying to run it hard to see where its limits are. So I think if you honor that and try to stay as close to that limit per flight, I think you'll have an engine that lasts as long as a normally aspirated AeroVee.
Nice. A couple questions here from some folks wondering about the maximum altitude you've had it up to.
Yep, 10,000 feet. So I don't have an oxygen system on board. I don't have a transponder on board. So legally, I can only take it to 10,000 feet, and that's what I've taken it to.
And Mike's got a question here. He's wondering, have you had any reduction in exhaust noise with the turbo?
Exhaust noise. Yes. Thank you for that question, by the way. That's a frequently asked question I just flat out completely missed. It is incredibly easy on the ears. It does not sound like a Volkswagen engine. It sounds better than any of the Rotax engines or any of the Cirruses with straight pipes burning around the field. It sounds awesome. And compared to what I used to have to do when we had the 4 straight pipes out on the engines, and I'd go out and my ears would be ringing for an hour after I held the tail down for my father. And now, I mean, this thing is just smooth as silk. Sounds great. So come fly it for yourself. You can judge for yourself.
Cool. As a data guy, have you gotten any data on that? You got any decibel
I haven't.
measuring?
A lot of people ask that. I think we've gotten to a point now, Tim, especially in Europe, where you are stricken, and in populated areas where you're stricken with noise restrictions. If they allow any kind of production aircraft in your airspace, including any Cessna, Piper, or Cirrus made in the last 5 years, an AeroVee Turbo will be fine. It's the quietest one of all of those.
Cool. Paul's just wondering, the turbo unit itself, does the manufacturer of that have any specified overhaul time frame?
Yes. Excuse me, they don't have a specified overhaul time frame, but they do have a service instruction that we have integrated into our manual. But basically, it tells you, if you're familiar with the turbo, it's one moving part, guys. One moving, two bearings. That's it. It's wonderful. It's like the simplest mechanical device I've ever seen. And you're going to know when your turbo needs to be rebuilt, because it's just not going to be holding or boosting anymore. So you're going to go in, you're going to replace the 2 bearings and maybe the shaft, and you're going to put it back together, and you're going to go fly. So no recommended interval is provided, but I guarantee you these are used on diesel trucks. They see very, very long service intervals compared to what you are going to be doing, which is if you are in the top 5 or 10% of recreational pilots, you're going to be putting 50 to 100 hours a year on this thing.
Sweet. Dave is wondering, is there any reason not to start my kit by building the engine first?
None. You have a beautiful coffee table when you're done. And motivation. I don't really honestly have an opinion there. I think it's a great starter project to put an engine together. and it's a great finishing project to put an engine together. So you do it whenever you feel the time is right. But yeah, I mean, I really consider it therapy, as I know most of my coworkers and family do, is building airplanes is therapy. So putting engines together is therapy too.
Cool. When you do build an engine early and let it sit around while you're building the rest of the kit for however long that takes, is there any preservation recommendations that you have with the instructions then?
No, we don't. It'll be fine within reason. You got to keep in mind most of these parts are steel, so they will rust if left untended or uncoated. So once you take, and by the way, our engines aren't shipped pickled either. So if you have an AeroVee engine that you received, you should take some care and time to put coats of oil on things that you think are showing signs of rust. Turbo, by the way, the turbo itself will rust because it's made of a steel as well. So you should take some care to pickle it, whether it is unassembled or whether you just have assembled it. But I think just turning it over, a few times a month is probably good to get some oil flow through there.
And John's just wondering, do you recommend a mechanical or electric manifold pressure gauge?
It doesn't matter. We have both in our test cell, and I think Joe and my father would agree with me that they've been within zero point 0.1 inches the entire time. So I think I don't have a personal preference other than if you're going to use one of these all-in-one instruments like you've seen me on these slides, then I'd recommend not doing a redundant system. I don't see that as necessary.
And Dan's wondering, do you recommend CHT and EGT instrumentation on all 4 cylinders for the turbo?
Yes.
Or is
For
2-cylinder instrumentation all that's needed?
I think you should do all 4. Again, you ask 5 people here at Sonex, you probably get 5 answers. But I think, especially with this instrument you see in this picture, which is the new MGL system, and now the guys at Grand Rapids have a similar one, and just about everybody else that makes a all-in-one package has the capability of having 8, 10, 12 probes. So why not use the capability? If you're going to go all steam gauges and you're a real purist and you are limited by the number of EGT and CHT inputs, I would not have a tremendous amount of heartburn if you only monitored maybe the back 2 cylinders or whatever. But again, you're going to know if something's not healthy because it's not going to be making the power like you expect or like you've become accustomed to. But I think with today's technology, there's just no excuse not to monitor everything. That's just my opinion.
It's so nice having that data too when you're done with a flight, and you can get analysis on it now through different sources, and it's wealth of knowledge. Yeah.
Yes, it can be a blessing and a curse, but let me just show you real quick up here, Tim. There's a little SD data card right here in the slot. So after every flight, I religiously pull that data card, download the data, and analyze it, at least at a basic level. And then here is my iPhone right here in the green case, and that is running a piece of software called Cloud Ahoy. I just love what they've done with it. And it has a GPS track and performance data, and now they've integrated it with video feeds, so you can basically save all of your performance stuff in one integrated package. It's really cool.
Sweet. Yeah, it is.
More to come. Yeah,
Oh,
I mean, they don't pay me anything. I'm a paid subscriber, but I really think what they've done is cool, and I think there's a number of other companies that are pursuing similar setups.
Yeah, awesome. A couple questions here from a couple different folks about the extra horsepower, increased horsepower, and how that integrates with the shrink fit prop hub. Any concern, question about that?
None. As I said before, I'll stand by this statement. It's the strongest prop hub out there certainly for any VW conversion, so 100 horsepower is not even breaking a sweat for it. Engines are a funny thing though, guys. Engines are a funny thing. They are, as opposed to the turbo being one of the simplest mechanical devices out there, a internal combustion engine is about as complex as it gets and intimidating from just about every design standpoint. The reason I maintain my confidence in our system and what we've set up is our vast experience with it. And our thousands and thousands of flight hours worldwide on the system has just proven itself through the years as a robust system.
Question here from Steve. What determines or controls the manifold PSI?
What controls the manifold pressure? Your throttle setting. So thank you for asking that question, because I know there were more than one of you out there wondering that. You can't separately control your manifold pressure. It follows from a throttle setting. So while you could do it with RPM, we just have been disciplined about, we don't really care as much about what the RPM is. We care more about how much are you putting pressure into the system? How much are you stressing the system is a better way to say it. So that's why we're so concerned with manifold pressure. The RPM just falls out of manifold pressure, and that's all controlled by the throttle.
And another question, Robbie's wondering, why does the AeroVee assembly manual state not to run the engine without a prop?
Yes, an unloaded engine is a dangerous thing. So back to when you look at the engine system, the engine package, if you don't have the front end loaded with something, you can create harmonics, and the RPM, the engine itself will just run away. So it's just not an advised thing to do. Oh, the propeller also provides cooling air, so you aren't providing any kind of cooling to the engine at all. Excessive ground running is a bad idea, period. But ground running without a prop is a really bad idea for those two reasons.
MacArthur's wondering, would billet CNC machine Nicocell cylinders meet the requirements of the AeroVee Turbo?
I don't know. I don't know. I'd have no experience with them. So, you know, you could become an experimenter, wear the badge proudly, purchase those billeted Nicocell cylinders for, what are they? $5,000 to copy, $5,000 for a set of 4, something like that. I'm just guessing here, but I've done a little bit of research on them, and you can go try them out. I just don't think it's worth it.
Wow, $5,000 for the cylinders. That's
for the ones he's referring to. Now you could make your own and then maybe save some money, but they aren't cheap.
A set of standard seal cylinders. What kind of money are you talking about there?
I think they're about $500, something like that, for the steel cylinders.
Wow, 10 times.
Don't quote me on that. I'm
no.
getting further away from the sales environment every day and more into the R&D. Oh, there's this jet thing going on. It's been an obsession, to say the least.
All right, so let's talk about performance again. Dave's wondering, will the turbo affect the performance of the Xenos?
Sure. Yeah, you add power to any airplane, it impacts performance. I think the fascinating combination, to me, is any individual out there who would want to take on some time to climb records and put a Turbo AeroVee on the front end of a Xenos and see how we can get it going, especially if you don't care about hurting your engine for a real record chaser. You've got yourself, build a really light Xenos, put a Turbo AeroVee on it, and oh my Lord, go. Go chase the sun.
Jordan's wondering if you got any information or knowledge if the Turbo will have any impact on insurance.
None. I mean, our safety record in the airplanes in general, while as of late has been a bit disappointing for explainable reasons, our safety record is remarkable, and the insurance companies know this, they notice this, and they reward this. So if you don't get too crazy with what kind of engine package you're putting on, and largely the insurance carriers and underwriters have looked at Sonex very favorably, and manufacturers in general, the ones that are reputable. But if we bless an engine, and that's kind of the unique thing about Sonex, it's coming from the airframe company as well. But if we bless an engine, the insurance carriers consider that very favorable. and reward you with a low rate.
Awesome. Varn is just wondering, where do you measure the CHT?
Yeah, we measure the CHT with our own probes. We have a little probe that has a screw in it, a self-tapping screw. We put it right next to the spark plug, right in the head. And we found they're just a few degrees different from those super annoying, awful spark plug gasket type CHT probes. Oh, expensive, awful, hard to service, hard to remove, hard to put back in CHT probes. So use ours. You just use a little self-tapping screw and screw it into the head next to the spark plug, and away you go.
It sounds
Use
like you
it
don't care much for the ring type spark plug gasket CHT, huh?
Anyone with experience with them would echo my thoughts.
Oh yeah, yeah. Question from Paul. He's just wondering about the engine assembly DVD. Will that also have the turbo information in it, or will it be a totally separate publication?
No, and this is the interesting part, and thank you for asking that question. It was well timed. Our AeroVee DVD assembly video is really, really old. It was filmed, I think, back in 2003, if I had to guess. And as I said, just about every single system in the engine has changed somehow, subtly, or quite a bit. So the AeroVee DVD has largely just become a visual guide. It's a reference. This is how it goes together. It still goes together the same basic way. A lot of the core parts are the same. But the conversion parts, when we get to that section, they look different. They go together a little different. So we're looking at that whole project. The manual that I referenced before has really become the go-to guide for how things go together. So when you have a conflict between the video and the manual is it. Regularly updated, regularly revised.
Okay, great. Well, we're getting close to the end here. We've had a lot of comments thanking you. Good information, good presentation. I like how the engine sounds. Jack Pelton made a nice comment here. Good job tonight. Rose says hello. Let's take on our last question here.
Hello, guys. And by the way, Tim, if I may, thank you for those kind comments. I really appreciate it. Our family appreciates it. And I think everybody at our company, I just couldn't be more proud of how aggressively we're pursuing innovation and doing it at a reasonable cost. That's really what we're all about here. That's because of all of you.
Awesome. Thank you for that. Yes. Robin, just last question here. We'll get your opinion on something. Robin's saying, if you are considering competition aerobatics, which is the better engine to consider, the AeroVee Turbo or the Jabiru 3300?
Man, how much money you got?
Wind up on. Yeah.
Yeah, right. How much money you got? No, I think, that there's an economic component to that. And I think it's important to note with the AeroVee Turbo and with the AeroVee series, the propeller hub area, it screws oil back into the engine, but there is a little gap there. So if you really wring this thing out, you're going to splash some oil out of the engine, period. So I think Jabiru has taken some more care, obviously with a purpose-built engine, to seal up the engine a little bit better. So for that reason alone, if you're going to do a little more negative G, etc., I might consider going with the Jabiru, but I'd certainly put an AeroCarb on it because the Bing Carb is just not going to be the right choice for that. But if you're looking, I think the AeroVee Turbo will certainly get you the performance there. And if you're going to do sportsman class aerobatics, nothing that won't work with this system in doing those mainly positive G maneuvers. You can have a lot of fun with it.
Good answer. All right, well, that wraps her up. Thank you so much for being with us tonight, Jeremy. Excellent presentation, great pictures and information about your new engine there. Sounds exciting. Any closing comments you want to make to the attendees?
No, I just, again, really appreciate all of your support. I mean, I know we've taken some really big bites, especially in the last few months, to get some projects that we've been working on for years finished. And the only way that our family and our team could possibly do it is with your understanding and your support. and your enthusiasm. So unfortunately, I've been isolated more and more from customers and getting that kind of feedback as I move into research and development. But I promise I read all your notes. I promise I personally read all your feedback, and I'm interested in it. And we look forward to doing many, many more great things over the next number of years, as long as Lord willing, we'll be able to do this stuff. And thanks to Jack Pelton and Rose for everything you've done for EAA. It's deeply appreciated by us in our community. And let's get to work. Let's go have some fun. And thanks, Tim, as always, for being a gracious host.
You're welcome so much. Thank you so much for volunteering your time tonight to give us this very informative and educational webinar presentation. And to all the attendees, thank you so much for tuning in tonight. Have a great night, everybody. We'll hopefully see you next week, where Mike Bush will be talking about a mechanic's liability. Good night, everybody.